Okay, guys, so lesson 2.2. This is over understanding rational numbers. Now, we've pretty much already covered this, so hopefully this should just be a review. You really want to look at your notes and your vocabulary from lessons 1, 2, 3, and 4. Okay, so 1.1, 1.2, 1.3, 1.4. Okay, the essential question here is how is an irrational number different from a rational number? Okay, that's your essential question. Vocab, irrational number, is a non-repeating infinite number. So, for example, I put 0.247583 dot dot dot. Okay, that means it's infinite because it's got the dots after it. Nothing's repeating. Okay, be careful of stuff like this. 3.5757757775 dot dot dot. It looks like it's repeating, but all it does is have a pattern. A pattern is not enough for repeating, so that is still considered an irrational number. Okay, your square root here, all right? Now, for those of you who don't know square root, I looked at the definition and I was like, all that's going to do is confuse you guys. So I went ahead and just showed examples. Now, first, I want you to realize, in case you don't know it yet, squared. Okay, so in other words, we have 3 multiplied by 3, or 3 squared equals 9. The opposite of squaring something is the square root. In other words, the square root of 9 equals the square root of 3 multiplied by 3, which equals 3. Okay, our first 3 perfect squares are 1, 4, and 9. As you can tell, the square root of 1 is 1. In other words, 1 times 1 is 1. The square root of 4 is 2. 2 times 2 is 4. And the square root of 9, as we went through up here, is 3. In other words, 3 times 3 is 9. Okay, so square roots are important. We're just going over perfect square roots in this lesson. Okay, if we come over here, we do a little bit of a review on rational and irrational numbers. Okay, now here's what I want you to understand. We have to be able to identify throughout all of these which ones are rational and which ones are irrational. 2/3. If I do this the short way, okay, and I'll show you how to do that real quick, see if you guys can get up this little bit of extra. So I have, and I write 3 again anyway, I have 2/3, right? If I can go through and multiply this by something to make 9, in other words, 6/9, then I know that this is a repeating decimal. In other words, it equals 0 and 6/10 repeating. That is a rational number. Anytime we have something that's a repeating decimal, it's a rational number. We just proved it can go exactly into a fraction. The square root, I'm going to erase this real quick. The square root of 25 equals the square root of 5 multiplied by 5. I'm just giving you a little bit of extra information. So the square root of 25 is 5. That is a whole number, so it's a rational number. This one, even though it's negative, is still a repeating decimal. That means it's a rational number. You just learned in the last lesson how to turn that into an exact fraction. You would have to follow all those steps again and find out that it's a rational number. Rational, root word ratio, right? Ratio means fraction. If it fits into a fraction, it's a rational number. This one is a whole number, so of course, in order to make it a fraction, all you have to do is put it over 1. That's a whole number. Okay, that's a rational number. So most of these are all rational numbers. Then we get to the last one, square root of 2. Now, if you punch that square root number, if you punch in the 2 and the square root, you're going to find that you're going to get a non-repeating infinite decimal. Okay, this is what we call an irrational number. Another irrational number that you should be familiar with is pi, or otherwise known as 3.14. Now remember that 3.14 is just an estimate of pi. It actually goes like this. It is also infinite and non-repeating. Okay, guys? Now I have one quiz problem that I think once I give you this hint, it's going to make things a little bit easier. At least I hope it will. So I'm going to go through and show you guys, okay? So this is it, okay? So here's the thing. They go through and they make this quiz problem kind of confusing, okay? So everything that they question in this is about the area, all right? The reason they're talking about the area is because it's the same squaring something. In other words, 20 multiplied by 20, this would have an area of 400, okay? So, however, the question says to go through and add another foot onto each length. Now, when I'm sitting there and I'm thinking length, I'm thinking length multiplied by width. But what they're actually saying is they want you to add a foot on to each one. Okay. So they want a foot all the way around. What this does is it makes it into, that makes it into a 22 by 22 square. So it's still a square. And if we find the area of that, it's 484. They're going to ask you a bunch of questions on that. You know, is the area a rational number? Okay. And so you want to go through and make sure you check off all the ones that are true or false. Let me see if there's any other notes on that. No. So what I wanted you guys to realize when they add a foot on each side, there's a foot here, a foot here. That means we're adding 2 onto the 20. So this becomes a 22 by 22 square. Okay, guys? That's it for this one. Make sure you ask me questions in class if there's anything you don't understand.